All right. How's everybody doing? How was everybody's holidays? Did you have a nice time? Did you get some rest? There's no rest, only progress? Yeah. I tried to take some time off, but it was like super busy nonetheless. But what are you going to do, you know? Here, I'm just going to set a few things up here. Make chat bigger so I can actually read what you're saying. Nice. Yeah, I'm glad it was chill for the IR folks, or at least for you. Maybe not for all the IR folks, but... Okay, so Nub on the Discord was talking about this Floxif malware, and I was going to take a look at it myself instead of me just doing it all on my own. I figured I would hop on stream and we could take a look at it together. So this is quite an old piece of malware. Here's the... Let me link the bizarre sample so y'all can follow along if you want to. And then Nub put this blog post / raw notes together that basically just goes through their triage process and getting to the point where they got to some control flow obfuscation, and then they could see things like stack strings, etc. And I'll get to the control flow piece here, and I'll show you what this looks like because this is tiny on the screen. But basically there's some return oriented control flow that breaks disassemblers like Binary Ninja, and then it makes it really hard to analyze. So I thought that'd be something fun to look at today. And hey Lobsec, how's it going? Yeah, first stream of the year. So here's a virus bulletin, not virus total, article from 2012, which talks about Floxif. So obviously it's like 13 years old, but what's kind of funny about these file infectors is they never really die, which is why they keep popping up more and more. I think Sergey and Sean refer to these as zombieware because they just continually spam sandboxes and IOC feeds and whatever, and they're kind of hard to get rid of because of that. But regardless, there's some pretty common functionality. Let's see here if I can make this bigger. So acting as a module, Floxif can use the exported functions of SimServe DLL as some sort of API. Two export APIs are contained within, let's see here, SimServe naming floodfix and CRC32. The virus gets its name from the floodfix API. The CRC32 API is a continuous loop to a sleep function with a 1 minute interval. So once the SimServe module is properly loaded into the host DLL, the virus will execute the floodfix API. And let's continue to look at what this API does. So just trying to provide some background on what this functionality actually does based on some prior research, so we're not just doing this all ourselves. Hey newbie, what's going on? Hey Duncan, how's it going? Yeah, doing well, thanks. Duncan, I purposefully updated my x64 debug before this stream just in case you came around. So you wouldn't get upset with me. So continuing on here. First, it changes the protection of memory used by the host DLL between the start of the PE header and before the section header. Let's see here. Page execute rewrite. Then it restores the virtual address and the size of the base relocation. Afterwards, it resets the protection of the same memory to page. Okay. Let's see here. Okay, it changes the protection of the whole text section, then resets the protection. Finally, jumping to the entry point of the host DLL, it executes the original file. So the main function of the floodfix API is to restore the host DLL in its original form in memory and to execute the host DLL starting at its entry point while the virus runs in the background. So, okay, so there's the anti-analysis trick here. So we can go over this and then we'll take a look at it ourselves so we're not just reading a blog post this whole stream. But before we go further, let's take a look at Floxif's anti-static analysis trick. If the malware code is not encrypted or binary dumped from the decrypted code, we can quickly take a look at its functionality using static analysis. Let's see here. because the disassembler can't render it properly, right? Which is kind of what I just talked about. So just to show you, so if I open this up here, and if this isn't big enough, I can make this font bigger, but it gets kind of hard for me to use when I'm doing this. And Duncan said, thank you, good sir. You should get the many types plugin too while you're at it. It's the best thing since sliced bread. Okay, cool. Yeah, I'll definitely check that out. Probably should do a proper stream on it too. Could be even smaller if needed. Okay, cool. Thanks, Rico CZ. Okay, so yeah, so if we look at some of this, so we don't want to be in HLIL. So Floxif, or sorry, Floodfix has these exports. So if I go back to what those look like here, triage summary, in the exports pane here, we have CRC32. So that was that sleep loop that they were talking about. Then it just adds these two exports. So Floodfix, these have different ordinals. So these actually might be different functions, but I'll take a look. So they might be, we might have to call these by ordinal if we do some dynamic analysis, but we can figure that out later. And then if I go to one of these, for example, Floodfix, then we can see that there's these instructions that are followed by these non-disassembled bytes. So if I go into one of these function calls here, we can see there's a push AD, a call, a push with EAX. Then we have a move of the return address because it's the current stack address plus 4 into EAX, add 4. We push the EAX address onto the stack, and then we do a return. But if we look at the, let's see, did I keep it open? No, we could just, if we look at the x86 documentation here, sorry for the flashbang, we can see there is a near return to calling procedure, and then we pop the amount of bytes from the stack. So let's see here. If we do, I don't know what, it must be the opcode. Yeah. So the opcode designates whether it's a far or a near return. So if you look at the opcode here, C2 or CA, and then if I scroll down here, so in this instance, this is going to be a C2, which is a near return. And then once those bytes are popped from the stack, so the amount specified in here, then it's basically going to modify the address that is going to be returned to, I believe. So if we go back to this right up here, go down here, you could also look at Nub's blog post there, but let's see. So the lines of code highlighted in the figure are not junk instructions, junk code, or corrupted data. The disassembler and debugger can't disassemble it, of course, because they're extra bytes added after the return instruction. By default, the disassembler will interpret the code after the return as a new function, and it will look like jump/corrupted code. So that's what we saw there. And the call to the reroute function leads to another call, this time reroute 2. Using static analysis, the disassembler won't be able to follow the return 8 instruction. We can assume that it will jump to the caller. Hence, we will just end up at the first call. So using a debugger, if they follow the return 8 instruction, this will lead to another routine, and it will jump to another location, instead jumping to the location straight after the return. So the location just after the first byte. So if we look at this again, this will effectively jump to, if I scroll down here, this will jump to this 8B. And if I create code at that location, then there's what looks like correctly disassembled code, but then we get invalid instructions here. So let's see here. What are the opcodes here? 8FF. So we'll have to figure out what those invalid instructions are from, but basically the whole idea is going through these call sequences will obfuscate the control flow to end up at these differing offsets and therefore breaking the disassembler. So what I wanted to look at is whether or not we could patch these. So perhaps like in this particular instance, I don't know why these bytes are not disassembling properly, so that may be another issue. Whether we could patch these return instructions and then figure out exactly the which offsets are going to be returned to by these call sequences. So these are pretty easy to identify in Binary Ninja. So if I go to the low-level IL, we can see this becomes a kind of, well, in my opinion, more clear. So we have the normal push operations. So this basically just lifts it one level into, this just lifts it one level up into their intermediate language called low-level IL. And then this gives us more insight. So that return 8 instruction becomes this ESP plus 8, and then jump to temp 0 being the pop operation. So basically it will perform the pop, so we'll get the previous call instruction, so here, and then I believe, let's see here, and then if it's ESP plus 8 after the pop, that will have, if I go back here, and then it basically does the same thing again, then yeah, it should go to those instructions after that call. Here, where are we at here? Do you sometimes reverse APKs in the stream as well? Not a ton, but I do want to do some Android stuff at some point. I think it would be fun. DACJan1244. Fine, I'll learn Binary Ninja this year. So if you actually do want to learn Binary Ninja, I'm just going to plug our training, which lets me do all these free streams and stuff. So we have a Binary Ninja malware analysis course if you want to check that out. But anyways, enough plugging. So let's get back to this. So, hey QZ, how's it going? I have IDA training. Oh, cool. Nice. Need to get Binja. Yeah, so you can, if you upgrade to premium, it's just like the cost difference between them, and then you can get access to both courses if you're interested. Lots of APKs from Android boxes that are like hubs for resident okay, yeah, I know what you're talking about. Interesting. Thanks, guys. Yeah, I appreciate you recommending the course stuff. Okay, so let's look at flood fix 2. And if we disassemble after this offset, this is a little bit cleaner. So we get a call to virtual protect here. And I think the H or like the ILs should show this a little bit better. Okay, if this isn't valid, okay, we might need to patch this to make this valid, but that's okay. Or to make it lift properly, which I can definitely do. So if we wanted to do that, for example, what's up, dude? Hope you had a good holiday. Now that it's over, I expect to get back to work. Yeah, me too. Yeah, it was good. Yeah, a lot of family time, but yeah, back to work now for sure. Everybody's asking for the AMBT stuff, so I'm working on that furiously. Not furiously, but feverishly. A lot. I'm working on a lot. Is it finished yet? No, it's not finished yet. Crap, that whip, yeah. Yeah, I'm working on it. It's going to be good, I promise. There's a lot of crazy stuff that's going to be in the course that I think people will like a lot. But yeah, I'm going to have like a bunch of stuff, updates in the upcoming months and stuff on where things are at and when people can start accessing it and whatever. So stay tuned for that. So, okay. So if I look at patching this, I can just NOP these. I know I can do this from the UI. So work equals sweat, getting rid of bad stuff seems fine to me, Dingus. Yeah. I wouldn't recommend writing the course while under fever, doctor's orders. Yeah. Yeah, thanks for the blog link. But yeah, Binja is cool. Cooler if everything in the Pro was for community as well. Yeah, like it's pretty affordable. So definitely check out Binja if you can. Just because there's a lot of functionality that comes with the personal license or whatever license you end up getting, that's really, really good. So, and they have like multiple architecture support, et cetera, et cetera. It's like quite comparable to Ghidra in terms of what's included, but I like their Python API and a bunch of their functionality a lot more. So that's why I use it so much. Is binary emulation available for CE? So I think if you're doing emulation with the plugins, then no, it's not available in the community edition, unfortunately. But I think their debugger is. So I'll have to ask the Binja folks. You need to get rid of the bad blood. Yeah. Okay. So I keep getting distracted by chat. So let me just patch this real quick. So I think we can do, I'm just going to undefine this. So 3B. I wish I could select these two addresses. Maybe I can just do it from here. Okay. So I'm just going to do bv.write, and then we have the address. So this address. Do I need address bytes? Can bv.write only write to a single address? Let me check. Have you tried Keeling or Keeling? Yeah, I have. So I have a really old blog that I don't really update anymore, but it has this post on it. And you can all look at my old blog if you want. But yeah, I talk about emulation with that tool. It's pretty cool. I just closed the tab I needed. Okay, so do write binary view. I think we want a writer is what we actually want, but writes the bytes in the data to the virtual address. Okay, maybe this is actually just what we need. Okay, so we'll do bv.write and then this address. And then I'm just going to write, I don't know what format this is in, but it's probably just like this. Okay, there we go. So all I did there was wrote two NOP instructions to that return and then that proceeding byte. And then we got like a proper disassembly here. So if I scroll back up, we can do that again. So hit Control Z. Maybe. Can I not unpatch stuff? Okay, yeah, so if I do that again, so C was just the C3, 3B. So this is the invalid byte afterwards. And then if I do the write, then it nops them out, and then we get proper disassembly. So I know there's some like IL rewriting stuff that we might want to take a look at, but I just figured for today we could do like classic byte patching with NOP instructions because I figured it was easier. So if you're wanting to follow along, I'll just pass this in chat. Are you doing CTF challenge or malware sample? Yeah, it's the flood fix stuff that 8KSR mentioned. Let me link Nubs. So this is Nubs blog from the Discord, and then here's the sample if you want to follow along. Yeah, no problem. Okay, so let's see here. Nice, they updated it with some really cool uses like Ethereum VM, some router architectures. Yeah, nice to see you, 8KSR, by the way. Get your stuff so I can sub on Twitch. Cool, yeah, okay. So let's continue. Why not IDA? I've been doing a lot of IDA stuff lately, so I did a video with Hexrays, like in collaboration with Hexrays, in December. So I'll just link that in case anybody missed it. But I just wanted to go back to using Binja for a bit because I've been using it a lot lately, or using IDA a lot lately, rather. So if you want to check out the IDA video, it's here. I should have mentioned that at the beginning, but okay, let's get back to this guy here. Okay, so pop AD, and then we have another jump at the end here. So let's reverse what this is doing. It looks like this might be broken too, this call far instruction. But we're gonna get, so I think this is probably floodfix 2. Okay, yeah, so this should decompile. So I'll set this up over here. Okay, so let's do LP address. This is going to be arg4 plus 3c. So I think this has to do with that API. Let's see. So yeah, they just did the knob trick as well. So the byte FF address was added to disorient the disassembler to emphasize the point. Modifying the byte FF to be a NOP will yield the proper representation of the code, which the call to SimServ reroute will be jumping to. This anti-static analysis trick is an attempt to force the analyst to perform dynamic analysis. Yeah. Okay, so let's see what else we got here. The floodfix API found at simser.dll doesn't do anything other than restoring the host DLL at its entry point. Some dynamic analysis approaches involve modifying the instruction pointer to start at interesting parts of the code, assuming the data and code are properly configured. If Floxif is aware of this method to implement an anti-dynamic analysis trick, Floxif hooks KI user exception dispatcher API. Any attempt to change the EIP to anywhere within SimServ DLL might result in error. That's interesting. So this would probably like break a system if it's modifying all the DLLs. And then now the infection routine. So yeah, that's basically what I want to analyze is the infection routine. We know that the infection routine is not triggered in floodfix or in the CRC32 API. The infection routine is triggered once the SimServ DLL is loaded into the memory space of the infected DLL using a call to load library. Thereby, the virus is already infecting the system in the background while the floodfix API is called. Let's see. I think there should be, after hooking KI exception dispatcher, it creates, okay, so we can look for the mutex. But I wanted to see if we could like auto-magically patch all those routines, if you guys are up for that. About what this session. So I'm just looking at this file infector that folks were talking about on our Discord. I love RE112. I should really get a bot to talk about the topics or whatever, but here, I'll just link the blog post I just mentioned earlier. There you go. Okay, so after creating the mutex, it stores the name of the system, Windows, and temp folders using get system directory. Okay, so it does avoid infecting the Windows system DLLs, which is good. Next, it starts enumerating the modules for each process running on the system using the create tool help 32 snapshot API. Let's see, each module's path is checked against those folders. Okay, that makes sense. Then renames it. Okay, it doesn't actually talk about the infection routine, or did I miss that? Whatever, we can just analyze it. But this should give us a good starting point because I don't know how much this thing has actually changed over the years. But okay, so these Floxif API calls are probably, okay, I need the disassembler again. Or disassembly, not disassembler. Because I can like effectively knock out this call too. So are these, yeah, okay, so these are called like everywhere. So we can probably figure out all of these areas that are being broken by this trick. And then patch these out in order to recover the control flow. I think that should be pretty easy. I just don't know if this is the only function that does this or if there's others, but I guess we could just mess around and figure it out and then restore the database if we need to. By the way, Josh, or Virus Bulletin, what year is it? Yeah. Hey, Sergey, how's it going? By the way, Josh, what VM do you recommend for anti-VM? Is there like a hardening tool that I can use? I'm actually looking at this as well, but I think there's some, I can't remember. VMware Harden Loader. Like there's been a bunch over the years. I just don't know how many are still accurate. Like I don't want to point you at a GitHub repo and for it to be super outdated. Sandbox KWT. Hey, do the binary ninja offered by the course is the real paid one or rather the trial one? Also, is it usable on my own machine or in a detected lab? So yeah, so the for our course, you get a full Binja license. It's a personal license, so you can't use it commercially. But yeah, it's the full version of Binja. It's pretty sweet. There's some guys in custom key setup, but I can't find it anywhere. Yeah, so I was just messing around with Cape v2. I don't know if they have hardening scripts in their repo. Let me see. But when you're setting up Cape, there is stuff that you do to remove. So like, for example, I was literally just doing this yesterday. So you add these like replacers, and these will modify KVM and QEMU to prevent like certain values from being running in the QEMU virtual machine that can be easily detected by malware. There's like 10 million ways that you can detect a virtual machine. So it's kind of like, this is just preemptive stuff that you really want to address. But I'll just link this. Could I RDP into the Cape VM? So Cape you kind of just want to use for automating analysis. And then if you're doing manual analysis yourself, you could just set up a hardened VM yourself. Yeah, it is kind of insane. So actually, I couldn't get it to work. And I submitted this pull request yesterday. So yeah, I'm contributing to Cape. I submitted this PR and it got merged because they broke Yara Python recently. It's not super exciting, and they have like Gemini Code Assist. I thought this was kind of cool. It like reviews the PR and stuff. Yeah, shout out to Duart and Young Binary. Yeah, shout out for all the folks who work on Cape. It's really good. And Dude Raven, Kevin. What happened to our... Okay. Yeah, this whole install thing is insanely broken. I have this good repo of a guy who has a bunch of techniques. Oh, cool. Nice. Yeah. Yeah, it's pretty cool. Okay, so before I get more sidetracked, I think I answered all the questions. But yeah, there's some hardening scripts in the installer directory as well, like Win10 disabler, or I think this just disables stuff. But I do know there's some auto hardening scripts out there. I'll just need to find them. Okay, so let's get back to the sample. So I think I can just at least off the bat look for calls to this particular function, and then we can just patch those automatically. So to do that, we can use the little Python console here. So I can do bv get function at, and then let's see, actually no, we can do something better. Yeah, I think we actually have to get the function object first. So get function at here. Oh no, we can do get function by name. Functions by name. And then use this. And then obviously we just want that one. So I'm just gonna add this to my script here because I keep using the snippet editor on stream and then I keep screwing things up, which could easily be avoided by just using a proper IDE environment. Or well, I know people don't consider VS Code a full IDE, but Zero Louise MX, yeah, Sergey and I have known each other for a long time. We used to work together too. Okay, so for, I think it's just f dot get callee or callers, caller sites, and then for site in, and then let's do print site. And I'm just opening the BNDB in a different instance here just so I don't mess up the one that I have running. So that's why I have that. But if I go down here, so okay, actually let me back up a little bit. So I'm using Binja headlessly here, and you actually need the like commercial version of Binary Ninja to do this headless stuff. So I just wanted to preface that, but you can do everything that I'm doing right now, like in Binary Ninja in this open instance I use snippets a lot, which is just like this little snippet editor. But again, I just kind of wanted a full dev environment because I wanted the language server to be running in the background. So site dot Oh, maybe we're not going to get the autocomplete like I wanted. There should be, let's see what the site is. Enumerator is not callable. My other possible route is to create some insane keyling script that hooks and patches all the VM detect methods. Yeah, so Sergey and I could both attest to this, that like, it's just like emulation is so hard. Like I want it to work so bad, but it's just, it takes so long and there's 10 million gotchas and just addressing, like I like where your head's at, but I'd probably try and do anti-analysis stuff within like either a debug environment or within something like Cape first, rather than trying to do emulation. But yeah, you're definitely on the right track. It's just like emulation for me was so much work. Yeah, Sergey's literally been working on this for years. So, okay, so ref, and then I just can't remember what type this is. Reference source. So I think it's Python API. Okay, and then this has function. So I just do dot address. Oops. Okay, so then now we have all the call sites to where that like ret instruction is called. So then so the only thing I don't know is if this address is going to be, or if there's always just going to be 2 bytes between those, but let's just start with that. Actually, we can actually print out the instructions. I guess if it's always a call to the same function, it'll always be the same amount that it's skipping over. So I think we can just safely do bb.write. Let's see, at site.address. Okay. And if I copy this, I'm just going to run this in the snippet editor so that we can see it in real time. So there should be one that gets overwritten here. Let's see here. So it's going to be call. Oh, no, wait. We want to C40. We want to go all the way from here to here. So it'll be like way more bytes than that. Y'all are chatting amongst yourselves. I thought maybe if I tell Claude Code or something good agentic to read the Keyling framework docs, read the VMware repo I pasted earlier with all those bunch of VM detect methods, I could probably come up with something if I'm too lazy. About using Keyling for security research, I saw QEMU could be a better option. Keyling uses QEMU, actually not the same QEMU, don't be confused. Yeah, it uses Unicorn, which is like a stripped down version of QEMU. But I think that's what Sergey's already saying. But when people say QEMU for VM, what they mean is CVM QEMU, which is a hypervisor built on the same tech, not emulation. Yeah, exactly. So what's kind of funny is, so on the new Apple Macs with the ARM architecture, I was using full emulation QEMU, which is pretty wild for an x86 machine, because that's like the most accurate way of running a VM. It's pretty slow, but with UTM, which seems to work pretty well. Okay, so we're gonna get the, is it always gonna be, no, it's 2 bytes. Okay, I was right. I was just tripping. So if I print out, okay, I'm not gonna patch it right just yet. So it didn't actually patch anything, so just ignore that output. Okay, so we already got to our knob, so it's gonna do, but we actually want to skip over 731. So we want to skip over this call, or we could patch this call too. Maybe let's just patch it. So it'll be 1, 2, 3, 4, 5, 6, 7 bytes. So let's just do 90 times 7, and then I'll copy this, and we'll run in our little database here. Actually, I'll just get rid of this And we can just, instead of copying and pasting back and forth, I'll just use that. And then we can do run script here. Let's see, patching must be bytes, byte array, or string. Did I screw that up? I'm tripping. Didn't we just do this earlier? Oh, it's because the address first. Okay, sorry guys. Okay, and then I'll copy this and then run script. Okay, so then it's patching the calls, and then now it's reanalyzing everything. So in theory, the control flow should be fixed in this entire sample now, I think. Let's see here. I think this is doing the offset patching, which is why it looks kind of crazy. But so if we go to, okay, yeah, it might not be, like, see, why is the function, maybe I have to redefine these functions, unfortunately. Okay, yeah, so I just hit U there, and then that part of the function also became a part of this. But now we get clean, kind of clean disassembly, or decompilation rather. And somebody mentioned it in chat, but this Infector, I believe, is written in C++. So we get some, I don't know if this is RTTI type information or if it's, let's see, we should be able to find it. So Binja automatically, yeah, here it is, I think. No, it's the directory table. Binja will automatically parse the, yeah, here it is. So the RTTI, so the runtime type information from C++. So it'll automatically parse those and adds a bunch of the class information to the binary automatically, which is pretty nice. I think IDA does that automatically now, but it didn't for a while. You need to use a separate plugin. Do you have some tips to make it actually usable? It takes like a minute for the start main open. Any of you experience? So Sergey, for UCM, I've had pretty good experience on my M2 Mac, but it's a Max CPU, I think. So I think that might be why. Any of you experience with Looking Glass? I don't know what Looking Glass is. Are you talking about Spotlight? It sounds kind of similar. Yeah, basically what I was trying to say earlier about UTM is basically I just throw my beefy Mac at it and it seems to emulate okay, but it's still super slow. Looking Glass got bought by Foxit. It was an Intel service. Fox IT. I think this is just DuckDuckGo sucking at searching for stuff. But anyways, we'll see if they respond. Okay, so I wonder if I can reanalyze the functions that are not analyzed in full. So these are tail calls now. But yeah, let me scroll through this function list that we just patched. Yeah, okay. So what I do want to do now is see if we can force the reanalysis of these functions, and then so we're not having to like hit U and then Binja automatically reanalyzes them. So maybe, let's see if I can find another example of that. Okay, so here, if I just hit reanalyze current function, oh, that doesn't work. Like I could just reanalyze the entire thing. Oh, zero Fox. Lookingglass.io. Hopefully I spelled that right. Open source application that allows the use of KVM configured for VGA PCI pass-through. Oh, that's cool. Compression. So it basically allows you to hook up PCI stuff to your VM with KVM. That's neat though, if I understood that correctly. Okay, so let's keep going. I wonder if I can force Binja to, here, I'll look up the docs. I should really just keep that tab open. I have a poor concept of what it does too. Okay, cool. Yeah, I'll check it out for sure. This is like half of why I do these streams, is so y'all can tell me about things that I'm not keeping up to date on. If I just do reanalyze, will it work? .analyze causes this function to be analyzed if it's out of date. It does not wait for it to be finished. Okay, so that's what I was trying to do, but Okay, that didn't work. So I wonder if I can just do the trick that I was doing through the UI. Data var, undefined type. Maybe we can disassemble. I don't know if this is going to be a thing. Because like the function's already defined, so can I undefine a function and then reanalyze it? So like for example, like that. Ew, that's kind of gross. Okay, that fixed it, but how do I do that automatically with automation? Maybe I should just write the patch code to disk. Oh no, now it's not working. Do you guys see that? Okay, let's see if we can just do this by hand, and then I will reverse this to do something more exciting. The problem is that there's a lot of functions that do this, but okay, so for example, there's this guy. It looks like this code still might be messed up, but this looks okay. So let me open the other database and compare these, and we can figure out if we patch this incorrectly. 4C, yeah, that looks right. But why was it? Okay, yeah, that was what just happened. Yeah, so same thing. So ADC, BN code start. Okay, so I just fixed this. And if we go to the high level IL, then we can see it does a get module handle where the module name is acquired using this ESI register. And if we look at the disassembly for that, let's see here. I'm just trying to figure out whether the ESI address is initialized to anything before that. Okay, I can't tell. It doesn't look like it is. And then if we, this will be the module, and then, okay, so it's loading the library. And it looks like these are being decrypted from this offset. So if I create a struct here, we can just start making, so this is C++, like I mentioned earlier. So we're gonna have different structs throughout this. So if I just do, if I hit the S key, then create struct one, and then hit the S on these offsets. So if I hit Control Z and then click or highlight this offset 0x3, this is currently an undefined offset within the struct type that I just created, so struct one. And if I hit S, then we can automatically create the member at that offset. Same with down here. So this is just a really nice way to reconstruct this. So I could say like source data, and then it's adding 4 on each iteration, and then it's accessing a value relative to the beginning of arg4 and var8. So, oh no, then it's adding 1. Okay, yeah, so this is just a string decryption routine, and it just uses relative offsets within what's provided to this function. So if we look at this, these cross references here, we could see that it's used for get proc address in all these locations. It's used in these calls, et cetera, et cetera. So let's figure out the data being passed to these and if we can decrypt them to recover the strings as well. So if these are passed at runtime, it might be a little bit hard. But let's just say this is our string data, and then we'll just say this is the key, and then current offset. And then we want, okay, so then if it gets to a null byte, then it breaks. So cur byte, and then string decrypted. Okay, and then we're returning the second offset within that structure. Not entirely sure why, but let's just say if we pull up the structure here, so if I go to the types, go to struct one, then we're just gonna have a char, so the second offset. So let's get char onc, or char dec offset maybe. Oh no, it's getting the address of that relative offset. So I would have thought if it was accessing, let's see here. Let's look at the disassembly to figure out the size. So EBP string data add 4. Okay, so it'll be not 4, but dword, or let's do int 32t unc red val, and then unc 3. Okay, so that's almost right. And then we're gonna have, let's just say unc 1, 2. This is kind of pointless because why didn't that fix that? I'm assuming this red val is going to be the string instruction, or sorry, the decrypted string. So let's just say this is the void pointer because this is 32-bit dec data for now. And then unc 4 is going to be string decrypted. Okay. You guys are still talking about, yeah, this is Sergey's bread and butter, so I have a poor concept. Okay, we already went over that. Let's see here. You can just natively use Intel IOMMU options and KVM QEMU to pass a GPU to the VM. It's very straightforward. If you have a spare sacrificial GPU that you want to make available to the malware. No, don't say sorry. I like it. It's good. It's good when chat's active. When I'm just reversing these boring structs. Okay, so then we'll do unc 3 is going to be the key again. I need to fix this because I messed it up in the bottom. And then string decrypted. So if the string is already decrypted, then it just returns the decrypted data address. So, oops, is okay. So pretty basic structure, but you kind of want to reverse these so you understand, especially with these C++ routines, exactly what's going on. So then if I go back here, where is it getting this from? Yeah, give me EX. So EX, okay, so this is an argument. Arg at ESI. So I think the arguments might be messed up here. So if I go to function, okay, so let's continue here. So let's edit this function so that it has the correct prototype. So if I select MW XOR string, hit Y, and then I think if I just do this, and then we're returning a void pointer, then arg1 will be what's being referenced for the structure. And then I need to retype this to struct 3, or struct 1 rather. Okay, there we go. And then now if I go back to where this is called, and then we look at the data here, then this is probably some sort of encoded data. So we can see there's these zeros, B1, blah, blah, blah. So this is some sort of XOR encoded data. So if I want to get the key, then I can actually just apply, I think this should work. I can just retype these to the same struct that I just created. So if I do struct 1, not a pointer, then the key here, yeah, I'll probably have to fix the structure because it's not right. But I think this should be the key. So we can make this an let's see. So it's going to decrypt it in place. And then, oh yeah, I just wanted to make this unsigned so it doesn't show up as a negative. Okay. And then if we go back here, so I think this should just be a string here, and this should be the key. So if I do in this, let's do import struct.pack in this, and then we'll do our XOR with our key, which is 0xb1. Okay, I'm going to do this in a better way than this. Okay, do you just provide a string? Yeah, this is what I want. So we'll do, and then this, We need to import it using this transform, and it did not decode properly, probably the byte order. Oh yeah, the byte order shouldn't matter because it's just a single byte XOR. So maybe I'm misinterpreting this code. Let's go back here. Let's see. That looks right to me. Let's see if I can find another example. Yeah, those aren't valid. So what is it then? Yeah, let's see if I can figure this out. Okay, so it's XORing the full D word. That's why. So let's see, zeros out. It gets a byte from EDX, being the current offset, into AL, and then it XORs the byte with the D word. And then move this out into ECX. So if we look back at our code here, and we XOR this, let's just grab a good example. All right, let's try, so this is a D word, and this is the data. So let's just do the first D word. I don't know why it wants to make it negative so bad. Like I'd expect that to be valid string data, but it's not. So there's got to be something I'm misunderstanding about the code. Let's see here. If we go back, okay, current offset +4, yeah. And then key 1 is the second offset relative to arg1. So yeah, I'm definitely applying those markups properly. And then we have these stack based ones as well. So same concept, I believe. So 0, 1, 2. Yeah. So let's try this example. So let's look at the ASCII table. Okay, let's wait out of range. There must be something I'm missing. Because this is effectively getting the 40th offset within this stack string. And then it's just providing that like effectively as the structure. Let me see if it's modifying the key. Definitely not. Current offset, let's see here. It's because it's doing a not. Yeah, I think that's it. Not D-word byte, and then it writes the byte. Okay. So a bitwise not in Python will be what? A squiggle or something? Yeah, it's the squiggle. So then what I just don't know is if it's doing a not on the D word, but I think that doesn't matter. And then it gets the last byte. Like, yeah, it's just going to change the, let's see. Okay, well, I figured this out. I'm just going to run to the washroom real quick, and then we'll continue. Does that sound good? So I'm just going to run a quick ad. So for those of you who don't know, I run this training in addition to doing a whole bunch of other stuff, reverse engineering services and training. So if you're interested in this stuff, definitely check out our website. And I'm just going to play a quick ad for that, and then we'll continue. So be right back. Hey everyone, my name is Joshua Reynolds, and welcome to the InvokeRE Introduction to Malware Binary Triage course. Throughout this course, you will learn to triage and reverse engineer malware binaries using a number of proven techniques. These include static analysis, which is the concept of analyzing malware at rest, and dynamic analysis, which is the concept of analyzing malware as it executes. We will also be analyzing network protocols used in malware command and control communications, malware obfuscation, packers and how to unpack them, process injection, how to write effective YAR rules to detect malware variants, and how to compare malware samples at a binary level. This course consists of 11 modules, each containing lectures and practical labs to apply knowledge that you have gained as you complete the course. We provide both video and written materials, so no matter what your learning style is, you can complete the course successfully. Thank you for checking out the course, and we look forward to teaching you. All right. Hey, all doing. Then the XOR 0xFF. yeah, so Rangarage said bitwise not is the same as XOR 0xFF. So do the first XOR, then 0x, then XOR 0xFF. Okay, let me try that. Okay, where was that? Let's try this one again. So our original guy here. Okay, null byte. 2C. Okay, yeah, looks good. Sweet. Thanks, Rangarage. I was worried that let's see here. So it's like a not of the D word, but the D word is part of the XOR, and then a byte is being acquired from there. Anyways, I was just worried that I was screwing up the 32-bit register accesses and stuff, but obviously it was just the not operation, so that's great. Yeah, cool. So let's automate that. So we can basically now that I fixed this function call, the stack strings are going to be hard, but all of the ones that have these D words should be straightforward for us to decrypt. So for example, time to decrypt some strings. Yeah. I feel like that's all we do on this stream sometimes. Oh yeah, check out this cool coffee cup. If we've swag now, if people are interested. I should finish this. I just got a Coke too, so I'm literally going from coffee to a can of Coke. Okay, so like I said, so we can look for all the call sites, so the exact same thing before. So let's make a new deobfuscation script. Get XOR routines or something. And then we'll do basically the same thing, but now we want the XOR string, MW XOR string. This is going to be called something different though in our headless database that we're testing with. So let's grab that. That doesn't look like the same address. Let me copy that correctly. Am I tripping? It's just because it's obfuscated, so it's confusing me. Okay, this is our XOR routine. So let's see. PCX. Yeah, this is it. So let's copy this guy. It's kind of dumb to be working between two databases, and then we'll print out the caller sites, and then we'll use this database. So again, it's going to be kind of hard to get the stack string ones. We could probably figure out how to do that if y'all are interested. This is our deobfuscation routine. So do we want to start with the stack string ones instead? Because for the D word ones, I can just, okay, so for example, just to show you what I'm talking about, and we're not patching, we'll just say XOR call. It'll be the same as before. And then we're just going to do bv.get, I knew how to do this, get function containing our site.address, and then it'll be, it's functions, right? Get functions, and then we want the first one, and then f, let's see here, f dot get LLIL at. So kind of going from a given address to the LLIL instructions is kind of weird. So that's what I'm doing right now. So because we have the call site of the XOR call, we have the call site of the XOR routine, and then we just need to get the LLIL or a higher level representation of that. So I just need to get the low level intermediate language first. So that's what I'm doing here. But you need to get the function in order to be able to call this get LLIL at. So, and then we'll do site.address again. And then let's just print this out for now. Then we'll get rid of this search. We don't need. In all the instances where there's a call, so let's lift that higher so I can show you what I'm talking about. So if we do our LLIL to high level IL and then print that, get rid of this. XOR Avaloc says, I think I missed it. Did the built-in function get applied in the IL for the stack string? Yeah, it does. So it kind of gets messed up in these instances because there's some strings and then some. So like create service A obviously works, but let's see here. So like there's some instances where strings aren't obfuscated, but where's the obfuscation call here? We just had it. So here, let me see if I can find a good example. So for some reason these aren't getting folded, I think because the stack is messed up. But see how, like, for example, there's a built-in string copy here. So this is those built-in functions you're talking about. Oh wait, is this different? Is this 5.2? Hold on, let me check out this part of the blog post. I can't remember what this part was. Let's check it out. Custom string constants. Oh yeah, we should totally be doing this instead. Okay, so we actually helped with this. So Josh Reynolds from InvokeRE. I haven't used this new functionality yet, but we probably should. Let's see. So by adding a type, okay, so it's a custom string renderer. So I remember watching the stream on this as well. Yeah, I can share the hash. Here it is. I got to run into this issue. Or sorry, gotcha. I run into this issue too often as well. Yeah, which is why they implemented it. Okay, so let's do this. Okay, so they make lambdas. Cool. So I don't know. Let's see here. Recognize constant pointer. Class decoders. Function view read. Decoder. Derived string location. Okay. Create a new type. Attributes can contain parameters that can be accessed by your plugin. Create the decrypt function using a hard-coded subtraction key. Navigate to the location, right-click, copy as hex. Now apply the type directly. The type is not a pointer. Yeah, that's pretty rad. So this would work for the address references. So for example, so not these stack strings. Maybe it would, but maybe I'm just not interpreting this correctly. Let's see if I can show you the address ones that I was looking at earlier. So there's these. So there's these ones. So I think it would work for these. Whether or not I would have to like extract the key. So basically within this D word, the third byte is the XOR byte that we need to extract. And then the rest is the encoded data. Looked into the docs for Binja and it looks very useful. Yeah, it's super useful. We got this cool slider. Another useful feature is the custom constant rendering. Handles rendering a lesser known floating point format. Oh, that's cool. Nice. We didn't make custom string renderers for the specific feature. Part of the Binja vision and over the next few releases to push the toward language specific decompilation. Yeah, that's awesome. Yeah, it is sick. Okay, so I'm assuming I can just repurpose their plugin, their example one, because this is kind of similar to the example binary that I gave them. I'm assuming we can do it, right? So let's just try it rather than me blabbing. So let's just call this custom string dec. And then we need to, let's see here. So we're going to have XOR not. Oh, but this is going to be way more complicated. Anyways, let's just figure this out. Decoder.keys. Okay, that's just the keys of the, so it's just is valid type keys. I guess it doesn't really matter because we'll just get like a bunch of leading null bytes. So yeah, I think this will actually work. Function view read val I decoder byte. Cool. Derive string location. All right, let's give this a shot. Okay. Do we want to cast this to a byte? not cast, but yeah, let's just try it without this for now. Because down here it's going to get byte by byte. So that's all good. Okay, and then I just have to throw this into my plugins folder, the GUI. And then do, oh no, but we need the key in each blob. So let me modify, I don't think we need like this. Oh man, this is kind of complicated. Because the only thing I'm not sure about is how I can actually get the key from the defined type. So maybe I'll continue with what I was doing before, just because like this entire API is new to me. Do these Twitch videos get uploaded somewhere? Yeah, on our YouTube channel here. I just threw it in chat. Okay, let's just see if I can figure this out though before I give up. Okay, is valid type, pointer type. Okay. Okay, so it's just a byte 0. So here, I can just do byte 1. And then this will be, or 0, 1, 2. That's always the case, right? And then values is I. Yeah, it doesn't really matter if we, oh yeah, but we're going to hit the null bytes at the beginning, and then they're going to be invalid. So we just want this to be 4. So just to kind of illustrate this, illustrate what I'm doing rather than, all right, take care. Thanks for hanging out, a runny dude. Just so to illustrate this, so this is leading two leading null bytes, the hex byte, and then the key byte, and then another null byte, and then the encoded data. So here we're going to access the 0, 1, 2 offset as the first parameter into the decoder. And then if we look at the lambda that we instantiated, that's going to be the key. And then for the second parameter into the lambda, we have the encoded data being XOR'd with the key and then XOR'd with 0xFF, effectively performing the bitwise NOT. And then we're starting at 0, 1, 2, 3, 4. So we're skipping over these bytes. So 0, 1, 2, 3. So we actually, yeah, we want to start at 4. 0, 1, 2, 3, 4, and then we get to the encoded data. So now if I save this, and then see if I can apply it to the first argument for our XOR decoder function, then this should be a very good solution to this. So if we copy this to our binge directory, do I just dump it in here? I think so, right? And then reload the module. Argument must be module. Okay, so since the module isn't currently defined, I think we have to reopen this, reopen Binja. And then I'll use my first one with the control flow obfuscation removed. And then how do I define this type? Open the sample, create a new type. Attributes can contain parameters that can be accessed by your plugin. Now apply that type directly. This is, so the only thing I'm not sure about is, okay, so sub encoded is the routine. So let me just grab this sample real quick and then open this so I can know actually what's going on. Open it here. And then so how this sample works is there's these decryption calls, and then so then there's these sub routines. HLIL, it's probably a little bit easier to see here. So and then it's just being written to this output area, this .bss. So it looks like a section name, but it's not. So basically what they're doing is passing this hard-coded key into the type that's defined here. And then they are applying that attribute to the subencoded. So that's why this is possible here. Whether or not it is possible with a key that is being accessed at runtime, I think it still is, because I can just do what I was doing down here and talking about earlier, which is like acquiring these first bytes and then the decrypted data. So XOR alloc, assuming your decoding function takes no params, should be able to add the type char. Yeah. Would it be something like typedef struct1? No, it's all good. I don't mind you multitasking, but yeah, I think it would be something like that. So it's basically applying the attribute. So I think I can apply it afterwards. I don't think I have to make it I guess I can make it a type definition for struct1. Let's see. So here, yeah, struct1, because it doesn't automatically apply it. But yeah, I think you're right. So let's just hope that will work. And then let's see here. MW XOR string. Yeah, since we don't have to pass any parameters. And then star. I'll just do the exact same thing that they're doing instead of casting it to the struct1. Deobfuscate. The first argument to attribute must be the name. Must be a name. Isn't that a name? Subencoded. So what was in their example? What was subencoded then? The subencoded attribute will be used by our plugin from step 1. 2 args. Also, good day. Hey, sick in the mind. How's it going? Type def attribute encoded. So it's just because like our function doesn't actually take a parameter. Oh, the attribute defined is the Python. Okay, sorry. So encoded. So XOR not. Is that supposed to be what it is? Subencoded. Let's see. Let's look at their plugin. Yeah. So it's supposed to be XOR not. Type def attribute must be a name. Let me just make sure I have the right plugins folder. Yeah, it was in the wrong plugins folder. Sorry, one sec. We'll be using our first plugin. Deobfuscate. Yeah, I should be able to do this. Oh, when I was entering it. Why didn't it do it? Is it XORing stuff? I can't tell. I don't think so. Maybe if I apply it to this types as code stuff is crazy though. It's a good idea. Are you deobfuscating? I wish like it seems like this is quite opaque. Like it's hard for me to. Okay, let me try it with the argument. Well, work. This was 5.2 and I'm on 5.2 stable. Like, do you think I can get it to print out the debug logs? Okay, loading plugin. Loaded Python plugin custom string decryption. Man, I feel like we're so close. Result bytes location derived string. Let's see if I can get some debug log output. And then must be a module. Custom string decryption is not defined. What is my plugin called? Or what is it registered as? Encoded string recognizer? What do you mean it's not defined? Annoying. I feel like we're very close. Let me just restart Binja and see if it picks up those. Custom string decryption. Right? Like it's just making a D word. So it looks like. And no debug output. Maybe because this is a pointer. Okay, why don't we try it? I'll try the original with that sample and see if it works. Just for fun. This is the original. And then this is going to be our key. Oh no, that's going to be our defined type, right? But we want our key, find a type here. There's a little scratch pad. Maybe it's me. I gotta be doing something wrong because it's not calling the code. Maybe I'll ping the Binja guys after this and see why it's not working. And then I can probably have it like demo ready for next stream. But yeah, really cool having like the potential ability to have code as types effectively, and then being able to apply those throughout the database through just by defining a type is really cool. Yeah, I should probably go soon, just because it's getting pretty late. But let me see. I kind of wanted to show you what I was thinking with this stuff. So address will be our site.address. The HLIL at that address. I think the arguments might be miffed for this because of the control flow obfuscation. Like, let me see if that's the case for the original or for the deobfuscated database. So for that, I can do this, or maybe let's get a new line here. And then this guy is called something else. Let's try that. Question for the other programmers. Does anyone use Spring Boot in an enterprise environment, and why? Trying to convince the CTO at a small nonprofit that Spring is really slowing us down, and we should consider switching to Dono, Dino, TS. Is this like C++ Spring? Not that I can really give you advice on any of this, but that's a good question. Okay, so this is kind of what I was thinking. So, Java Spring. Okay, sorry. See, this is probably why I shouldn't be helping. So in each instance, there's a few different types of calls. There's one with a direct address, so that's the one that could have been applied with our string routine here. And then there's these other calls with these local arguments, or sorry, local stack addresses that are shown as these variable values. So if we go to one of those, for example, then again, we can see that this is the stack values that are being passed to that offset. We have our key, and then I think I can just set this decrypted data to a variable character array, but that's going to be different in each instance, so that's why this struct looks messed up. But and then these are just null padding bytes, it looks like. So essentially, we have to address like all those scenarios. So the stack offset capturing essentially the top of the stack, which has the struct applied to it, which helps because we're providing that as an argument, or we've typed that as an argument here. So that'll be struct one. And then let's see what else. And then these are similar, but they're at like these negative relative offsets to arg1. I don't really know why, but these might look better in like MLIL. Let's see. Yeah, these look a little bit better in MLIL. So these are probably the scenarios that we can address next stream, and then we can figure out, like, even that virus bulletin white paper didn't have the functionality for how it performs the file infection. So I think once we get the XOR strings, it should be pretty straightforward to reverse now that we've addressed the control flow obfuscation. And then I'll ping the binge of folks to see if I can figure out why the XOR routine isn't working when I apply the type to a given argument and variable, etc. So hope everybody enjoyed the stream. I know it's kind of slow with me learning this new custom defined type API, but I think this is probably stuff that's going to be important going forward, so that we're not, having to solely rely on capturing all these values manually and then applying the types based on the arguments found, et cetera, et cetera. It could be way faster based on what we're doing here. So hopefully I can figure that out. And even like with their example, I can't figure out exactly why it's not working, but it's probably just something I'm doing wrong. No, you didn't derail things at all. You reminded me that I should totally be using that new API, because they were talking to me about it, looking for those XOR examples, which is why we were mentioned in the blog. So cool. So yeah, I'll just play that ad one more time. Again, the reason I can do these live streams and provide this free content is because we do this malware analysis training, and we provide services as well if your companies might be interested in that. And so definitely check out our website there. I'm just going to play a quick ad for that, and then we'll find somebody to raid. So be right back. Hey everyone, my name is Joshua Reynolds, and welcome to the Invoke RE Introduction to Malware Binary Triage course. Throughout this course, you will learn to triage and reverse engineer malware binaries using a number of proven techniques. These include static analysis, which is the concept of analyzing malware at rest, and dynamic analysis, which is the concept of analyzing malware as it executes. We will also be analyzing network protocols used in malware command and control communications, malware obfuscation, packers and how to unpack them, process injection, how to write effective YAR rules to detect malware variants, and how to compare malware samples at a binary level. This course consists of 11 modules, each containing lectures and practical labs to apply knowledge that you have gained as you complete the course. We provide both video and written materials, so no matter what your learning style is, you can complete the course successfully. Thank you for checking out the course, and we look forward to teaching you. All right, so just to finish things off, let's find somebody to raid. All right, let's raid this person. Really appreciate everybody hanging out till the end. And all right, take care, y'all. Have a good week. I'll see you later.